This lesson is about sparse matrices. In our previous lesson, we looked at how to store dense matrices. Recall from our earlier topics about default dictionaries and how we use them to store sparse matrices. Here, we will look at NumPy implementation of the same. To get started, go ahead and download the dataset from this link and save it in the same folder as your notebook. Once done, import all the required libraries for this lesson. Let's start by looking at the sample dataset. It's a list of pairs of strings. These strings correspond to Yelp user IDs. A pair A-B exists if user A is friends on Yelp with user B. Pause the video here and take a moment to look at exercise 1. In the markdown cell below the exercise, note down what this particular code cell does. Hopefully, you could figure out that this code cell simply forces the target and the source edges to be created as well, but in the reverse order, and then drops the duplicates. The data frame edges now thus contains A-B pairs as well as B-A pairs only if A and B are not equal. Moving on to sparse matrix storage. Let's quickly look at how a previous method for storing sparse matrices based on nested default dictionaries works and performs. This code cell includes two functions called sparse matrix and a dense vector. Look at the code within these functions to recall how we worked with sparse and dense vectors in earlier lessons. When done, go to exercise 2. This exercise asks you to perform matrix multiplication of A and X. You can assume that the keys of the sparse matrix data structure are integers in the interval 0 to S, where S is the number of rows or columns as appropriate. Recall the element-wise multiplication concept of the matrix multiplication. When y is equals to x, y of I is sum of all j for aij into x of j. Breaking this down to code, we iterate over all the rows nested in a dictionary using a.items. This gives the keys and the values of the dictionary. The keys are the I values and the values of further are dictionaries. We will now iterate over these values. Using row I.items, we get the j values from the keys and the elements aij of the matrix from the values. As discussed earlier, yi is the sum of all aij into xj. And that's it. The matrix multiplication is done and this function returns the Y matrix. You can run this code cell to verify if our function works correctly. Moving on, let's go back to our sample data set and convert the edges input into a sparse matrix representing its connectivity graph. To do so, we'll first want to map names to integers. This code cell implements that for you. Recall vnames from above, which is a set containing names of source and target nodes. Here, we are creating two dictionaries, one for mapping the names to integers and the other for integer IDs to names. Now that we've mapped the names to integers, let's create a sparse matrix which has a value of 1 if the source and the target edge exists in the data. Let's start by calling an empty matrix G, using the function we defined above. We then iterate over each edge that is present in the data and set the ij element of the matrix to be 1. Remember, the I and j values can be obtained from the dictionary mappings we performed in the previous cell. Let's run this code cell and check if our implementation is correct or not. In the above, we constructed G using integer keys. However, since we are after all using default dictionaries, we could use the same vertex names as keys. In the next code cell, we will construct a new sparse matrix H, which uses the vertex names as keys instead of integer indices. Let's look at this code for implementation. It's quite simple and in terms that every edge is now mapped with a value of 1. Now that we've created sparse matrices G and H and learned how to perform matrix multiplication using dictionaries, go ahead and try exercise 5 on your own. This asks you to perform the same matrix multiplication we tried above, but with keyed vectors. Once done, you can check your solution with the test cell given below, and if it all works well, you can move on to the next lesson.